we have started. This is mathematical tools. As we know that physics is incomplete without mathematics. So here your basics will be clear. If you face any kind of problem when you are solving physical numericals, then if it is happening with you, then you need to gain information of basics of mathematics that I am going to discuss with you. Here we will start with this yeah, with this hold on, where are you, with this trigonometry. We will start from scratch and it'll end till the end. Okay, we will end till the end. So it has been started. I hope you are ready. You are with me for the next 1 2 hours. I know most of you are familiar with this word, trigonometric word, but if you know, then it will be a revision for you. If you don't know, then this will be first discussion of this with you. uh, physics physics is basically mm, 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 look at over here. Physics is basically a combination of a theory. Yeah, this physics is a theory and calculation. When it comes to calculation, as we know that when it comes to theory theory, okay, we know that physics is a theory, but when it will come to calculation of a physics, whatever is happening in a nature, then calculating of that happening phenomena, then we need maths. Okay, maths, that's why we study math, basics of math, just for physics. Not all, whatever will be a requirement of mathematics for this physics, then those topics we need to understand. So here for calculation we need to learn some mathematical tools. Okay, for calculation, not for theory. So here theory is coming. It is telling you that whenever you will be understanding theory, then at the same time calculation will come, numericals will come. So numericals will be related to theory. Are you understanding? Numericals will be related to theory. This numericals will be part of a theory of your chapter. Clear? Calculation is not separate completely. Okay, look at over here. What is angle? We have started this angle is what we take. At least we need to take how much? Anybody needs to take two line segment. Either you can say line segments or ray. Two line, this one and this second. Two lines, at least two lines you should have. Or if you have more than two lines, then you will have more angles. Okay, but right now if you have two lines, it means you will be able to create one angle with two lines. As you can see, I have right now this one and this one. These are two. So here only this will be able to create two angles. Okay, two angles. No, only one angle. As you can see here, this one angle. So how to form angle? Just you will have to take two angles, two lines, then just connect this vertex, one both ends of this both lines, connect together, then you will get. And this angle, this is angle, this rotation, amount of rotation is angle. Okay, definition of angle is that just amount of rotation. What is the amount of rotation? That amount of rotation will be considered as an angle. So this amount of and you know that this is nothing but just a radius of the circle. This is the radius of the circle, and this from here to till here, it is nothing but just arc of the circle. Okay, remember this L2 is the arc of the circle. This L1 is also, here we considered it this arc which is coming by the help of two radius, this one radius and this second radius. So this type of arc we can consider it as a L. Okay, it as a L, but name of this is what? Arc. Now next we have theta. Here theta is the angular gap or angular between line L and L2 by definition. Next we have angle theta is equal to, if you want to calculate angle, but you will have a given thing, is that two given thing. First, what is a measure of arc and what is a measure of a radius. Okay, if you have given this arc and radius, then you will be able to find theta. If you have given theta and a radius but not the length, then with the help of this formula you will be able to calculate the arc. Okay, so this is just a small formula just to calculate arc, radius or angle. In above diagram, so it can be written as theta is equal to L upon R. The unit of angle is a radian. Just unit, we are talking about unit. Okay, unit of angle, and this radian is a standard. It is considered as a standard. Either you can say yes, unit of angle is a degree, but this degree is not a standard. Clear? Yeah, this is your choice. You can say unit of angle is a degree, but for standard you will have to say yes, unit of the angle is a radian. Angle has a two direction. Yes, first just clockwise, like that, clockwise. This, hold on, let me show. This is known as clockwise, and opposite of this will be known as anti-clockwise. I am saying clockwise, which means hands of clock. You would have seen hands clock. Hand clocks move in which direction? Of course, in this direction. So this direction we will consider it as a clockwise, and just opposite of this anti-clock. Anti, which means opposite. Clear? So remember, direction of an angle are how much? Two direction. These are two direction. Angle has a two direction, anti-clockwise, and here anti-clockwise will be considered as a positive. Okay, you will say yes, anti-clockwise. This, if from here we start from here, this is increasing. When you will start in this direction, it means you are decreasing angle. Okay? So this will be known as negative. Now next we have this, if we rotate line in anti-clockwise, which means if we rotate in this direction, in anti-clockwise direction, from O to A, from OA to OC, semicircle, it is talking about like that. This is semicircle. It is forming now semicircle, which means a half of the circle. So theta will be what? Length ABC upon length OA. It is telling you that this length, this arc length is nothing but just 3.14. Okay, 3.14. Remember, 14, and it is repeating. Yeah, this is 3.14. In fraction, it would be 22 upon 7 radian. Clear? And in radian, this we know that this is a radian, pi radian. Okay, pi radian, and pi radian is equal to, not completely but approximately 22 upon 7 radian. So remember, pi, this is just a semicircle is a pi radian. Okay, just pi radian. So pi radian is just a semicircle, half circle I am talking about. When you will take a complete circle, it means you are saying you have 2 pi radian. Okay, 2 pi radian. When you say 2 pi radian, it means one revolution of the circle, one complete revolution, 360 degree complete, 360 degree, 360 degree complete is equal to 2 pi radian. Okay, 2 pi radian. So remember, this half is a 3.14. From A to B, A to OB, creator circle theta या arc length upon this 1.7. It is telling you that just half of this semicircle from here, we know that this is what, this is a pi, we know that this is a pi radian, clear? Not just a pi, this semicircle is a pi radian. But when you will half of this semicircle, then here you will be getting how much? Pi upon 2, because it is a half of a pi, so this will be known as pi upon 2. And in number it is how much? Pi is equal to 180 degree, so here you are getting 90 degree, and you know that 90 is just a perpendicular. So this is a 90 degree, or you can call it as a pi upon 2. This is a pi, or you can call it as a 180 degree. Similarly, for complete circle, we know that for complete circle, look at over here. For complete circle, circumference of the circle, it is talking about this. I know that this is not complete. It is not a complete figure. If this is not complete figure, then I can say this is circle, this is circle, this is circle. I will not take this. Let's consider this is a circle. I know that this is not a perfect circle. Just assume, okay, just assume. Here, this is circumference, this border of the circle is known as the circumference of the circle. Now radius, it is talking about this, from a line which starts from the center, it ends till the a point of this on this circumference. So this line is the radius. Now it is telling you that angle is equal to circumference of the circle, this complete, and upon radius there. So this angle will be equal to this. If this is a 360 degree, okay, here you are saying theta is equal to 6 point, this complete is a how much? 6.282 radian, and it is in a number, floating number. So in pi this would be 2 pi radian. 2 pi radian is telling me that this is a measure of this is complete circumference of this circle. Clear? How much? 6.282. Now next we have angle can also be measured in degree. Yeah, there are two ways to measure angle. In one is the degree and second is the radian. You are familiar. So here, look at over here. Angle can also be measured in degree, where pi radian is known as 190 degree. We have two. One is a radian and second is a degree. You know that 2 pi is equal to 360 degrees, so pi radian would be 100 degree, and pi upon 2 is equal to 90 degree, and 3 pi upon 2, I think it should be 270 degree. So if pi radian is equal to 180 degree, so 1 radian would be how much a degree? This is question. So just 1 radian put, and here 180 will be as it, and this pi will come in the denominator, in the place of a denominator. So here it is telling you that 1 radian is equal to 180 upon pi. When you will simplify this, then you will get this much, 57.3 degree, 57.3 degree. Clear? This much degree, 57 point. This is approximately number. Now next we have here you one thing is coming, is that if you have given a radian, then you question is saying just convert a radian into degree, then you can use this formula. If you have given a degree and question is saying just convert this degree into radian, then you can use this formula. Both are linked to each other. Okay, here 1 degree is equal to pi radian. So here 1 degree is equal to pi radian. So 1 degree will be how much radian? This is question. So 1 degree, and here pi will be as it, then 180 degree will come in the place of a denominator. As you can see, 1 degree is as it, and here pi upon 180 degree and radian. Here you will get a degree into radian. Here you are converting a degree number into radian. Okay, but in this you were converting a radian into degree. Clear? Now we have some examples. Look at over here. This is in radian. This is radian. We can convert it into degree. How? Let's see. Pi upon 6 radian, and we know that what 1 radian is equal to just I think 180 upon pi. 180 upon pi. Let me check. Yes, 180 upon pi. So here we have this much radian, pi upon 6. So it is giving you how much? Here you know that this is equal to, it is what? This is a 180 upon 6. This is a 100. Just we converted it into maths. 180 and then upon 6, and just to simplify this, you will get 30. Same here. And pi upon 3. Pi is equal to 180. Just put 180 and then simplify this, you will get this much. Here what is happening? Just we converted this pi into 180 degree. Then we simplified this. After simplifying this, we get this much, and here after simplifying it, we got this much, 60 degree. Next we have trigonometric ratio for a right angle perpendicular. People have studied it a lot of times, but we will not have to ignore it at all if it is coming again and again. Here we know that there are 6 fixed functions of a trigonometry. We know first is sine, cos, tangent, and these are 3, and just opposite of these 3 are more. So reciprocal of this is known as what? This reciprocal of a sine is cosine, reciprocal of a cos is sec, reciprocal of a tan is a cot. Okay, you know that. So remember, ratio of a sine, ratio of each trigonometric function is what you will have to know. Okay, you should know what is the ratio of this trigonometric function. Clear? For example, this sine theta is equal to p upon h. Remember, according to theta it will change. According to theta it will change. Not this. We cannot say that here would be h, here would be p. According to theta here, this will be changed according to theta. Okay, but this ratio will not change. P will be as it, h will be as it. So ratios are fixed. So sin theta is a p upon h, cos theta is b upon h, just opposite. So tan is tangent is a p upon b, and cotangent is b upon p, and cosec is just a reciprocal of sine. So you know that h upon p, and sec is a reciprocal of cosec. No, cosine, yeah. So here h upon p is a ratio of sec theta. Okay, so b is nothing but just hold on. This b is nothing but this is a ratio. B is nothing but this is a base, and p is nothing but this is a perpendicular. H is nothing but just h is a hypotenuse. Always remember, hypotenuse will be fixed. Okay, it will not change. What will be changing? This p and this b according to theta. If you are taking this theta, say according to this theta, this would be perpendicular. Just opposite of this will be considered as a perpendicular, and whatever is left, it will be fixed. Okay, don't worry about this. This will be fixed. Here, if this is perpendicular, then you left this as a base. Clear? According to this theta, this will be known as a perpendicular. Just opposite of this, whatever side is coming opposite of this theta will be known as, you will call that opposite side as a perpendicular, and whatever is left, that will be known as a base. Okay, this part is done. So here, yeah, p upon b, you can say otherwise p upon h. This is nothing but this is the ratio of sine, and this is the ratio of cos. Here you can sine upon cos. So from here you are saying that tan theta is equal to sine theta upon cos theta. So on measuring the angle, theta is 37. This is a different that we are not familiar with this. Here to theta you will have to understand more is that theta 30 is equal to 37, and beta is equal to 53 next to theta. In that case, remember if 10:30 here, you are telling that 10:37 degree, value of 10:37 degree is how much? This much, 3 upon 4. Okay, and here 3 upon 5, and here cos 4 upon 5. Okay, 4 upon 5, and tan 53 4 upon 3, tan sin 53 4 upon 5, and cos so perpendicular is a 3, and base is a 4. P upon h. So this 5 will be okay. 3 4 5. Here P upon h. P is a 3 and P is a 4. B is greater than P, but P will be always greater. Yeah. Here tan. So tan is what? P upon B. According to theta. This is according to theta. Yeah, according to theta. Clear. In this part, you saw that there are two more angles. First is a 37 degree and second is a 53 degree. And in that case, P will be H will be 5 and P will be 4. P3 will B will be. This will be according to theta. According to theta. Next we have Pythagoras theorem. Trigonometric identities. We have trigonometric identities. Remember, a square of this ratio plus a square of this ratio is equal to this h square upon hs. It can be written as a sin square theta plus cos square theta is equal to 1. Okay. Even it can be proved that this is equal to this. If you put ratio of this sine and ratio of this sine, what will happen? Let put P upon H, isn't it? Then P upon H is equal to 1 is equal to 1, and here this h will come in the place of denominator. P plus P this 1. So here what is happening? 2P is equal to H. No, not in that way. This formula. Second trigonometric identity is tan square theta plus 1 is equal to sec square theta, and here 1 sec square theta minus tan square theta will be equal to 1. These are trigonometric identities that will be used when you will be solving questions. Then even I will use this when I will be solving questions. Then you will keep remember. Okay, this commonly used angles and their trigonometric ratio. Till the 90 we have seen till the 90. Till the 90 we have seen. We are familiar. Sin theta is this much, sin 30 this much, sin 37 is this much, sin 45 is this much. Sin 53 is equal to 4 upon 5, sin 60 degree. This is for you, brother. And just opposite of reciprocal of this would be known as cosec 0 degree. So reciprocal of this is what? Just undefined. Next we have trigonometric formula. I am not ignoring all this. Yeah, all these angles I am not ignoring. Right now it seems it will be seeming yes I am ignoring, but when I will be solving questions based on this, then my focus will be complete on this. Don't worry. Just saying here this value of this is this much will not be more useful. Okay, I want to see result that yes I am understanding something very well valuable. It will be useful when you will be using this in your question. Then clear? Because trigonometric formula, we remember values of a sin theta, cos theta and tan theta, 4 theta, this, that, this, 0, 30, 37, 45, 53, 60, 90, 80. Yeah. For example, sin theta is equal to 1 upon 2. We know. This is very basic. But what if someone asks to you calculate value of a sine 120? In that case, what will you do? Directly, you cannot remember a lot of values of this trigonometry is equal to this. No, this is impossible. If you remember this, then you will forget uh, world what is happening in world. Okay, so there are a lot of things that we need to explore. We cannot stay on this only. So just to calculate value of this sine 120 degree, there is a process. Okay, that process we can use. Then we separate the given angle in term of this. For example, somebody is asking what is the value of this much. What is the value? Hold on, brother. What is the value of this much? 120. Here we will see addition or subtraction. Subtraction is that 180 minus 120, then we will get 60. We are getting 60. Either you can add or you subtract. So here when we will add, then what will happen? 90 is a standard. 90 is a familiar degree. So 90 plus 30. So 90 plus 30. We know that in which quadrant this is coming. 90 plus theta, it is coming in second quadrant. And in second quadrant, you are now that sine and r is reciprocal of this sine. These two trigonometric functions are positive. Remaining all those four trigonometric functions will be negative. That is what you know. So here this is coming in the second quadrant and we have a sine. So this is a positive. So this will be as it. Okay. This will be as a sine and it will give you positive sign. Where are you? Oh, I told you right now that this is equal to this is. Just either you can subtract this or add this, but it should, when you are adding, then this sum should give you 120. When you are subtracting one angle from other angle, then this is difference should give 120. Okay, 120, remember. So here right now we are not calculating, just we were observing that yes, sum of these two angles, the difference of these two angles, when to use, why to use, that is what we have seen. We will calculate this, don't worry. Here what is happening? Sine 2 pi, which means 2 in pi radian. Okay, 2 in pi plus theta is equal to sine theta, where n is a natural number. Here what is happening? 2 pi, first of all 0, it will become 0. With examples, let's see, with example. For example, sine 390, we know that 380 is a complete revolution, one circle revolution. So it is becoming sum. We are getting sum of two angles of 390 degree. Is that what? 380 plus 10. 380 plus 10. It is in degree. What about radian? So you know that 2 pi is a one complete revolution. 2 pi plus how much? 10 degree. Hold on. 360, brother. 360. So 2 pi plus 30. We will not take 2 pi. Remember, whenever you are observing 180 and 360, then trigonometric functions, sine, cos, all this will be remain. All this will be as it. But what if in the other case you are observing 90 plus theta, or 90 minus theta, or 270 plus theta, or 270 minus theta? I am saying that if you are observing 90 or 220, in that case you will change trigonometric functions. Okay, here we have 2 pi. 2 pi is nothing but just 360. So here we will not change this sign. This is sign into cos. Okay, into cos. We will not change. Okay, this is the rule. Here 2 pi will be as it. Here n is a 0. N is a 1, not 0. N is a 1. So this will be ignored here. Over here 30 we will take. So sin 30 is what? So whatever will be value of a sin 30 will be equal to sin 390 degree. So sin 30 is 102. No, 1 upon 2. 1 upon 2. This is the value of a sin 30. So here we are saying that this is a value of this is a how much? 1 upon 2. That is how we calculate a value of a big number, value of a big trigonometric ratio. Here this was the number which was big. 2 pi is equal to 3 and n is 1. So this was process, brother. This was process. Here we were adding. Okay? Now next let's see similarly here over here. Similarly with this. You know that in first quadrant all the trigonometric function ratios are positive. And here you are taking your sign will be positive, and here you are taking what? You are taking 360, and you know that the trigonometric function will be as it. Same here, trigonometric function will be as it tan. Look at over here, yaar. Look at over here. Pi minus theta. It means 180. So this is as it. And it is coming in second quadrant. So sine cosec comes in second quadrant. Cos pi minus theta. Here test is coming over here. Cos, look at over here, 180 degree. Yeah, then trigonometric function will be as it. But sine of this, you know that this is coming in second quadrant. You know. So if this is coming in second quadrant, so you know that there are two trigonometric functions in second quadrant which will be always positive, which are sine and cosec. But here cos is coming in second quadrant, but this is giving, it will give negative sign here, because this is not for second quadrant. That's in the second quadrant sine cosec come, that's why, and it is coming in second quadrant. So here we will use negative. Next we have this. Okay, 100 it will be as it, but pi minus theta. It is in second quadrant. It is not pi plus theta. Okay, it is pi minus theta, which means less than 100 degree. So it is in second quadrant, but tan theta in the second quadrant will be negative. Next we have equation. Let's take. So sine 120, either we can subtract or add. This is your choice. Here I am subtracting 180 minus 60. Both we can see here. If this PDF is subtracting, then we will add, don't worry. 180 minus 60 gives you how much? 120. This first will be ignored and this second will be taken. Now look at over here. This first angle will determine what will this trigonometric sign be changed or not. Who will determine this first angle? Okay, this is work of a first angle. 100 it is coming. It is telling you that this trigonometric function will be as it will not be converted into another trigonometric function because of a degree is 180 degree. That's why clear. So 180 degree, brother. What about sign? Sign. Hints. Positive, negative sign. So here, in which quadrant is it is coming? So this is coming 180 minus theta, yeah. So we know that sign is in second quadrant. It will be positive. So sign as it, okay. This is sin 60 will be what? Root 3 upon 2. This answer is telling you something. Do you know? This is saying that I am the value of this sine 120 is equal to root 3 upon 2. This is what is meaning of this answer. This is what is the meaning of this answer. Next we have find tan 150. Hold on. I promised you that I will subtract this. So let's fulfill my promise. Here we know that sine, okay, how much? If we add then 90 plus 30, yeah, 90 plus 30. 90 plus 30. Is it giving you how much? Sum of these two angles is giving you how much? Of course 120. Now we know that this is 90 plus, look at over here. We have this 90. Of course we will change this into this angle determines that trigonometric functions will be changed into another. So this sine will become cos because of this 90. So it became cos. Okay. This will be ignored. Now this will be taken as a theta. So cos 30 is how much? Of course you know that sine will be, hold on brother. This is question. Cos. So here look at over here, yeah. Look at over here. Here sine is coming. So it is in second quadrant which is positive. So sine will be positive. But when it comes to this trigonometric function, conversion of this trigonometric function, then this will be converted because of 90. It will be positive because of this. This is a sign, that's why, and it lies in second quadrant. So cos 30 will give you root 3 upon 2. So cos 30, as you know that cos 30 is equal to sin 60 degree. Yeah. Both will give you same answer, brother. Just it is your choice. Next we have tan 150. Look at here, 180 minus 30 is equal to 150. So here tan 180 minus theta, yeah. So it is coming in second quadrant, but it will give you negative because this tan comes in third quadrant, but it is coming in second quadrant. That's why. So here, what is happening over here? Sign will be negative. Clear? Will this function be changed or not? So answer is that no, because of 180. Because of 180. Okay, 180. 180. So tan will be as it, sine would be negative, minus tan, how much? 30. So you know that tan 30 is nothing but I think root 3 of 1 upon root 3. 1 upon root 3. This answer is coming. So minus 1 upon root 3. This is equal to how much? Tan 150. You are saying that tan 150 is equal to minus 1 upon root 3. Next we have sine pi plus theta. Okay. Next we have sine pi plus theta. What is happening over here? Pi plus it is telling that a theta is more than 180 degree, more than 180. So of course this is coming in third quadrant. Are you understanding? It is coming in third quadrant, and in third quadrant we know that there are two trigonometric functions that are positive, which are tan and reciprocal is cot. Just these are two positive. Okay, but here we have sine which is coming in third quadrant. Now we know that this will give you negative sign. Clear? Now what about the conversion of trigonometric function? We will decide this angle. So here we have 180, so it will be as sine, but here hint will be operator. Yeah, now I would say operators, not sine. Okay, operators would be negative because of this is coming in third quadrant. That's why this was reason. Yeah, it is done. Minus sign. Now what about this cos plus? So it is coming in third quadrant. Okay, I'm talking about this second in third quadrant, and yes, this is cos. It is giving you a negative operator. What about conservation? So here we have 180, so it will be as it minus cos tan. Yeah, this will be positive because of tan comes in third quadrant, that's why. And we have 180, that's why this will be tan theta, and addition is hidden, you know that. Yeah, so this was some important points that we needed to understand that, and we have understood. Next question we have sine 210 degree. Sine 210 degree. We are adding, okay, we are adding two angles. So what are those two angles? When we will add those angles, then those will give you how much? 200. So of course 180 plus 180 plus 30. 130 decides a conservation of a trigonometric function, and second angle will be taken as a theta for the next step. So here we have this much, and it is equal to 180 plus 30. So here 180 is coming, so sine will be as it, but this is coming in third quadrant. That's why sine is coming in third quadrant, so it will give you negative. So negative minus the sine 30, it is giving you minus 1/2, and this is a value of a sine of 210. This answer is equal to this. Sine 200 is equal to minus 1/2. Okay, this is done, brother. Now next concept is coming, which is a little part of the concept. Next is telling you that this one. Yeah, I am talking about this. Sine 2 pi, look at over here. 2 pi is equal to 360 degree. You know that. Here 2 pi minus theta. It means it is coming in fourth quadrant. It is coming in fourth quadrant. What is coming? Sine is coming. So in fourth quadrant, as you know that, as far as we have knowledge regarding this, we say that here cos, yeah, cos, yes, and the reciprocal of this sec. These two are trigonometric function that lies in fourth quadrant of the circle of the Cartesian plane. So cos and sec, yeah. So sine is coming in fourth quadrant, yeah, then be it will be negative because of this is coming in fourth quadrant. That's why now we have 2 pi, which is 360. So yeah, trigonometric function will be as it. So here, look at here, minus sine theta, minus sine theta. Next we have cos. Cos can come in fourth quadrant with a positive operator. Yeah, as we saw the rules behind it. So cos theta operators would be positive because it is coming in fourth quadrant, and cos sec both are positive in a fourth quadrant. Okay, tan for tan it lies in third quadrant, but it is coming in fourth quadrant. That's why it will become negative operator. And it will be as tan this trigonometric function will be as it. So tan minus tan theta, clear, minus tan theta. So these 3 are done. We saw that these angles are coming in fourth quadrant. If angles are coming in fourth quadrant, then what do we need to do? We have seen. Let's take some questions based on this topic. Next question we have, find sine 330. We know that this is just subtraction of 2 angles. 360 minus 330. Big 360 minus 30. 360 minus 30. It is equal to 330. 360 minus 360. So sine, of course, it will become minus. Operator will become minus sine 30. This sign will be as it because of 360 is coming. That's why. So 360 are minus sine 30, which is minus 1 upon 2. Yeah, minus 1 upon 2. This whole is equal to this. This is input, and output came how much? Minus 1 upon 2. Next topic, which is it is also important. Yeah, we are understanding quadrant, fourth quadrant. There are some trigonometric functions which are fixed, and those trigonometric functions that come in particular quadrant, then what will be operators? That is what we are understanding. So in this first, it is telling me that pi upon 2 is nothing but this is 90. Here we don't have 3 pi away, we have just pi upon 2. So this pi upon 2 is equal to 90. You know that. So if 90 plus theta, it means this is in secant quadrant. This is in secant quadrant. So sine is positive, and reciprocal of this is also positive. If these two are coming in the in secant quadrant, then here you can say positive. Operators should be positive. But this angle is 90. This angle is 90. That's why trigonometric functions will be changed. This sine will become cos. Same here, cos will be sine. And yeah, operators will be negative because of this is coming in secant quadrant. But it is not possible to be positive with a cos in secant quadrant. Next we have a tan. First of all, this will become cot because of 90. Okay, because of 90. Clear. 90. Then but cot. What about operators? Yeah, operators will be negative. Let's take some question. Let's take some question. Here we have sine 120. Here we will add. So 90 plus 30. We have seen this 90 plus 30. Then it will give you here. This is 90. This is 90. That's why this sine will become cos, and it is coming. This sine is coming in second quadrant. So that's why this will be positive. So cos 30 is equal to root 3 upon 2. Cos 30 is equal to root 3 upon 2. This formula, which is very small, we use this so that we can calculate a value of a long degree of a trigonometric function. Please. Now next we have concept, which is this concept. Look at over here. It is telling me that pi upon 2 minus theta minus a angle which is less than 90. Angle which is less than 90. In that case, what do we need to do? Okay, if a angle which is less than 90, then you know that all the trigonometric function will be positive because of it is coming in the first quadrant. That's why clear. If all the functions are coming in the first quadrant, will be considered as a positive operators. Okay, positive operator. So functions will be as it. No, function will not be as it. If first theta is 90, and you know that 90, whenever first angle 90 or 220 is coming, in that case we change trigonometric function into another function. Clear? As you can see here, sine is over here, so it will become cos because of this 90. Clear? Reason is this 90. So cos, and you know that all this will be positive because of this angle. This second angle is less than 90. That's why it will become positive. All, not only this, all these 6 trigonometric functions. So positive cos theta here, sine theta, and tan cot theta, just a cos theta. Let's see question. Find this using above. And this using above rule, this rule 90 minus 10. Now here we have this much cos 30. Cos 30, you know that this is root 3 upon 2. Oh, with the rules, if this is this much, so subtraction will be what? Difference 90 minus 60. And this angle will decide what should be trigonometric function in this place. So this will be sine. This will become sine because of 90, and it will be taken as a theta for the next step. So sine 60 is nothing but just 1 upon 2, not a 1 upon 2, yeah, root 3 upon 2. Okay, this, and you know that this is sine theta is equal to cos 30. Sine 60 is equal to cos 60. Next we have a little bit concept, which is if a sine theta is in negative, then it will be as it. But cos here, this is in a negative, then it will become positive, and this is a tan is in a negative. Just here this operator will become positive cos, if this operator is with the cos. Then here we have sin 90 60, it will be, the operator will be same, say minus this, it will be as it. Next we have minimum and maximum value. What do you understand by this minimum and maximum value? Maximum, which means maximum, minimum, less number, maximum, more number. But in this context, what is the meaning of this maximum and minimum value? In this right angle, P is a perpendicular, H is a hypotenuse, P is a base, H is a hypotenuse. Just understand this explanation of this first line. It is telling you that P, this P will be less than H, but it can be equal to H. B will be less than H, but it will be equal to H, can be equal to H. For example, standard is this much P upon H, and here we know that P is equal to less than or equal to H. Here we are saying this is P upon H is equal to or less than 1. What about this? Here you are saying sin theta is equal to 1 and it will be less than 1. We have seen, as we know that if if sine 60 is root 3 upon 2, exact value of root 3 upon 2 is what? Just less than 1. We are crystal clear about this, that this sign gives you less than 1 or equal to 1. When will it will be equal to 1? When you have a theta as a 90, then sin 90 is equal to 1. But when you take a theta as a 30, then it gives you less a number which is less than 1. That is what it is explaining. Similarly, for negative angle, this will be sign will become opposite of this, -1, -1. Combining above two inequalities is giving you that this theta is coming between this. Now cos theta is this much. Yeah, we know that. Same here. Same here. Less than or equal to this. For tan p, here what is happening? In this side it is a negative infinity, and in this side this is a positive infinity. But it is starting from 0. It is starting from 0. It is telling you that this side it will increase from 0, and this side it will decrease from 0. Same here. What is happening over here? Look at over here. What is happening over here? Cos theta, when we will start from 0, then it will increase. Cos 0 is what? It is 1, yeah. Cos 0 is 1. Then it decrease. This is our we will see later. A small angle approximation in a right angle triangle. If theta is very small, then this will be less than h and h will be equal to b. See the diagram. B is equal to h. B is equal to h, but not completely. It is approximately equal to h. And here B is becoming P is a decreasing. If theta is very small, in that case B will be approximately equal to h. If theta is very less than, in that case, and P will be less than h, and it will be also less than B. We consider P as a arc, this P as a arc, and H and P as a radius. Yeah, you are correct. But remember, this measure of this B is not completely equal to H. Measure of a hypotenuse, not completely, approximately. Okay, approximately. Sin theta is equal to P upon H. P is a arc and H is nothing but a radius. In that case, we know that theta in a radius is what? Arc upon radius. Theta is what? Arc upon radius. Sin theta is theta. If theta tends to 0, so theta should be in a radian. Sin 1 degree is equal to 1. No, this is the incorrect way. First convert 1 radian into radian. 1 degree into radian. Then it will become, as you know, that 1 degree is equal to pi upon 180, and sine 1 degree will be equal to this much, pi upon 180 radian. Cos degree 0 degree is equal to P upon H, and if theta is very small, then H is equal to B, and here it will become cos theta is equal to 1, but it is approximately 1. Okay, this is approximately 1. Cos theta is equal to 1 if theta tends to 0. If theta tends to, meaning of this is that if theta is less, then it will be not completely equal to 0. This is what is the meaning. Something will be 0.11 something, but not completely 0. Okay, that is what is the meaning of it. Similar with this here. Similar over here. Look at over here. If a sin theta is equal to 0, here theta will tend to 0. It means it is telling that yeah, I am going to equal to 0, but it is not happening. It will not happen. Theta will not become to 0. Okay? Same here, same over here, same over here. Tan theta is this much for very small theta. Sin theta is equal to theta and cos theta is equal to 1. For a small, tan theta is equal to theta upon 1. And you know that tan theta is equal to theta. Tan theta is equal to theta. If theta tends to 0. Find the value of 5 degree. Now we have question based on this concept. First convert 5 degree into radian. You know that if 1 degree is equal to pi upon 180, pi upon 180. So here we have how much? 5 radian. In that case will be what? Just 5 multiple 5 multiple pi upon 1, and we will have to simplify this step. Then we will get this much, pi upon 36 radian. Here it is telling you that pi upon 36 radian is a small angle. This is not a measure of the side. It is an angle. Okay, this is angle. Now next we have sin 5 degree is equal to this much radian. This is what we are saying. Sin 5 degree is equal to pi upon 36. Clear? 36. Now next we have some trigonometric identity that are advanced. Here we are adding two angles, different angles, a plus b. Here a plus, which means here if there is a 50, then this b will not be 50. This is what is the meaning. If a is 50, then b will not be 50. It can be any number except 50. Only except 50. That is what is the meaning. This was just an example. Okay. Then here we are subtracting two angles. In this case we are adding. In this case we are subtracting. If this is happening, then you will use this formula. Clear? Formula is very simple. It looks difficult. Here sin A. First of all, sin A you will take, then cos B. Then here you are adding, then cos A, then cos A, then sin B, cos A, sin B. Same here. Just it will be as it. This will be as it. Here, if a cos is coming, then it will become opposite. Cos A, cos B minus sin A, sin B. Same here. Okay. Here you will get confused. Don't worry. I will tell you. Next we have find sine 50 degree using above rule. Let's see sine 50 degree. Okay, it is what? Two familiar angle we will take. Okay, not unfamiliar, not any random. So 50 is a difference of two angles. First is 45 minus 30. We took this. In that case, we are able to use. We are able to apply trigonometric identities. So sine A minus B, as you know that sine A into cos B minus cos A into sine B. Yeah, that is. So this formula you will use. And here you know that value of this is how much? 1 upon root 2. This is equal to root 3 upon 2, and this is equal to 1 upon root 2, and this is equal to 1 upon 2. And then in this step, just to simplify this, then you will get this much answer. And this answer is telling that this is equal to, this is the value of a sine 50 degree. I know that it is looking complex, but when you will simplify this to get exact number without any root, then you will see that this is a very less number. Okay, not too much big. Root 3 is equal to 1.7, like that, and it is a non-terminating. Same here, root 2 is equal to something, I think 1 point, not 1 point, yeah, it should be 0 point something 0 point something, not 0 point something, 1 point something. Then 4 to the 4. Next we have 75. It is giving you 60. No, yeah, 60 plus 50. 50 is not familiar. So can we say 30 plus 45? Yeah, this is familiar. In that case, we are adding. So sine A cos B plus cos A sine B. Okay, that is what we will use. This formula you will use, and these two angles are familiar. Okay. That's why this trigonometric identities we will use. If these two angles, sum of two angles are familiar, then simplify the substitute value of each this trigonometric functions, then simplify this. At the end you will get answer of this value. Next we have this much 120, 60 plus 60, but both are same. Don't worry, just use the trigonometric identities. Sin A plus B, sin A into cos B plus cos A into sin B. This is the trigonometric identity. And substitute value of each this trigonometric ratio. Then at the end you will get these fractions. Fraction. Here you are getting root 3 upon 2. This is what is equal to sine of 120. Next we have cos 120, 60 plus 60. Here we are adding, subtracting. Yeah, operators are just opposite. Over here. So cos A into cos B minus sin A into sin B. This is a trigonometric identity. Use this over here, then substitute the value of these trigonometric functions, then you will get this fraction. At the end you will get minus 1 upon 2. It is telling me that this is equal to this much, and tan 120 is equal to what? As you know that this will give you sine 120 upon cosine 120. Yeah. Find the cos of 160 using above formula.